That's what this slide says here. We're going to skip some of those examples above. This slide, if you've ever heard of the term factorial, that's essentially what we just did. We just did 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 9 NPR9 is basically equal to when you take the number 9 and you multiply all of the numbers below it. Because if you think about what's happening, if you have a baseball lineup, right, you have 9 slots, right? Suppose these dashes represent each slot of a baseball lineup, right? Well, for the first slot, you have 9 choices. You have 9 players to possibly put in that first slot. So you have 9 choices right there, right? Now, in the second slot, you only have 8 choices left to put in that slot because you've already filled the first slot. So instead of 9 players remaining, you have 8 to choose from to put in the second slot. And then down the line, for the third slot, you only have 7 remaining choices. Then down the line, then 6, then 5, times 4, times 3, times 2, times 1. And what we're actually using here is the counting principle. We're multiplying all our possible options for each slot. So that is equal to the 362,880 answer we got above, if you multiplied all those out. So 9 NPR9 and doing this, they yield the exact same answer. They're really just the same exact thing is what they are. So it's just 2 different ways of doing the same thing. You could do 9 NPR9 in your calculator, or you can multiply 9, 8, 7, 6, 5, 4, 3, 2, 1 out by hand. You get the same answer. It's 2 different ways of doing the same exact thing. Okay? Now, what's a little different is, again, going back to the example we said before, what if you have 15 players and you only want to select 9 in the lineup? That's a little different now. Suppose you have that. Then you have your 9 slots. You have 15 selections to choose from, then 14, then 13, then 12, then 11. So if you have 15 players, you're going to have a way higher number. So what you do in your calculator is this, 15 NPR9. So let's go back to Desmos and see what we get when we do that. 15, comma 9. Look at that. The answer is way higher. Times 10 to the 9th power. So that number is going to be over a billion. 1.81. That's scientific notation. That means move the decimal point over 9 slots. You don't have to remember that though, for now. So the number's off the charts basically. Way higher. Okay? So this one here, your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs on the CD? I know CDs are old school. You don't have CDs anymore. You just stream everything. But back in the old days, CDs, you would have basically a track listing on the CD. So what order would the songs come in? So if they're recording 12 songs, but they only want to put 9 of them on the CD, you would do 12 NPR 9. So you have 12 overall choices to choose from. You're only selecting 9 of them. This is the N, this is the R. So 12 NPR 9 in your calculator. And this will tell you how many different ways you could put 9 songs in order on a CD. So 12 NPR 9, let's see. 12, 9. 79,833,600. 79,833,600. That's how many different ways you could select 9 songs from a group of 12 and order all 9 songs differently. Okay? It's really massive when you think about it, because you have 12. Basically you're selecting groups of 9 from 12 total things. So there's a bunch of different ways you could select just 9 songs, and then you're ordering all of them. So how many different orders could you think of? All right? It's really a very massive number. Last one for this video. There's 12 runners in a race. How many different arrangements for gold, silver, and bronze are there? Gold, silver, and bronze basically means 3 slots. 3 total outcomes. So you have 12 people in your race, and you want to see how many different ways 3 winners could place. Gold, silver, and bronze are 3 different place winners, right? So it's 12 NPR3. Or the other way to do it with your counting principle is you'd have 12 selections for gold, then you'd have 11 selections for silver, and then you'd have 10 left over for bronze. If you multiply 12 times 11 times 10, or do 12 NPR3 in your calculator, you should get the same exact answer. So let's do 12 NPR3, 1,320. Different orders of winners are possible. So if 12 people are running in a race, there's 1,320 possible ways 3 winners could get gold, silver, and bronze.